Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Alkene stability increases with the degree of substitution at the double bond carbons. More alkyl substituents on the double bond carbons is equal to greater hyperconjugation, and inductive stabilization is equal to more stable alkene. The order is tetrasubstituted, trisubstituted, disubstituted, monosubstituted, unsubstituted. Moving on to the next step. Identify the substitution pattern for each option. Option A shows CH2 is equal to C, Me, et. This is a 1,1 disubstituted terminal alkene, two substituents on one carbon of the double bond, 0 on the other. Total substituents on double bond is equal to 2 disubstituted. Option B shows CH2 is equal to with a branched chain. This is also a terminal alkene, is equal to CH2 end, making it at most disubstituted, 1,1 disubstituted, with the terminal carbon bearing no substituents. Option C shows CH2 is equal to CH, vinyl type, with a branched substituent on the adjacent carbon. This is a monosubstituted terminal alkene, only one alkyl group on the double bond carbons total. This is the least substituted. Option D shows an internal alkene, C is equal to C with no terminal is equal to CH2, with substituents on both carbons of the double bond. The structure appears to be a trisubstituted alkene. One carbon of the double bond bears one alkyl group, methyl, shown as the shorter branch going left up, and the other carbon bears two alkyl groups, an ethyl and another group, giving 3 total alkyl substituents on the double bond. Trisubstituted, disubstituted. Moving on to the next step. Rank the options. C monosubstituted, least stable. A and B disubstituted, 1,1 disubstituted terminal, intermediate stability. D trisubstituted internal alkene, most stable. And for the final step, why other options fail? A and B are both disubstituted terminal alkenes, neither achieves the higher substitution of D. C is monosubstituted, the least stable. D, being trisubstituted, internal, with 3 alkyl groups on the double bond carbons, has the greatest hyperconjugative and inductive stabilization, making it the most stable. Therefore, the correct answer is D. Therefore, the correct answer is option D.